we learned yesterday that if you look at the degree of the polynomial, this is called the fundamental theorem of algebra. Whatever the degree is, that's how many solutions there are going to be. So when we're all done, there should be 4 solutions to this polynomial. So remember, we can start by figuring out what are the possible rational solutions. So you're thinking about the fact that P, the factors of 3 would be 1 and 3. Q, the factors of the leading coefficient would be 1, 2, and 4. And you should have started to make your P over Q list. So positive or negative 1 over 1, positive or negative 3 over 1, positive or negative 1 over 2, positive or negative 3 over 2, positive or negative 1 over 4, and positive or negative 3 over 4. So then we would look and see, we would actually type this polynomial into our graphing calculator and see, does it look like it crosses at any of these places, right? Because we don't want to do synthetic division 1, 2, 3, 4, 5, 6 times 2, 12 times, right? We want to narrow down the possibilities. So if you look at the graph, I already have the equation typed into y equals. You can see 3 places where it crosses the x-axis. Let's look at the one that's the most to the left. It looks like negative 1.8, I would say maybe negative 1.7, rough guess. So that's not in our list. Like negative 1.5 is in our list. That's what 3 divided by 2 equals 1.5. So, I mean, remember I showed you, you could test in your calculator, hit second trace and choose the value, and you can type negative 1.5. You'll see that's not right because it looks more like negative 1.8 probably, or negative 1.7. So that one doesn't look like anything in our list, okay? Look at the next 0. So that would be, it looks like about half of a unit left to the left of the origin to me. So maybe negative 1/2, and that is in our list. So what you should be doing is going ahead and trying negative 1/2. Like look at the last place where it looks like it crossed the x-axis. Again, it looks like maybe 1.8 to me if I had to guess. But that's not anything that's in our list. So your best bet is to go with negative 1/2. So you're going to take negative 1/2. How many of you had already started synthetic division with negative 1/2? Good. Okay, so I'm just, if you didn't, this is where you should be starting. Lay out your coefficients. 4, 4, make sure there's none missing, but there's not. Negative 11, negative 12, and negative 3. We don't need any zeros because it goes x to the 4, 3, 2, 1, and then negative 3. So go ahead and do your synthetic division with this. Give you a minute to do that. I'll go through the first round real quick just so you can check your answers. Negative 1/2 times 4 is negative 2. Add straight down, we get 2. Negative 1/2 times 2 is negative 1. Add straight down, you get negative 12. Negative 12 times negative 1/2 is positive 6. Then we get negative 6. Negative 6 times negative 1/2 again is positive 3, so we get 0. So again, guys, we could start to write it in factored form, but these are just, these coefficients would be, it'd be like 4x to the third plus 2x squared minus 12x minus 6. But I told you you're going to do synthetic division again with negative 1/2 because, again, look at the graph one more time. It touches the x-axis at negative 1/2. It doesn't actually go through it. So whenever that happens, it's going to be what I call a double zero. Like negative 1/2 is going to give you 0 again if you take these coefficients that we're left with and go ahead and do synthetic division again. So again, I want you to do that, and then I want you to see if you remember how to keep going and finish it. So negative 1/2 times 4 is negative 2. Add straight down, you get 0. 0 times negative 1/2 is still 0. Add straight down, you get negative 12. Negative 1/2 times negative 12 is positive 6, and we get 0. So let's keep track so far. Again, if the solution is negative 1/2, don't forget the factor would look like x plus 1/2, right? Because negative 1/2 plus 1/2 is 0. You're going to have that factor twice, okay? And then what's left now, we started with degree 4. Here it would have been degree 3, right? Because it reduces by 1 each time you do synthetic division. So now what we have left is 4x squared, a degree 2 polynomial, minus 12. There's no x term in there because we got 0 as the coefficient. 0 times x is just 0. So guys, remember, when this is still degree 2, you have to try to factor it. Did you notice these have a common factor in them? Like both of those terms can be divided by 4. So I'm going to bring the 4 way out front, just because that's what we normally do when there's a common factor, right? We put it in the front of everything. And 4 divided by 4 would make that x squared, and negative 12 divided by 4 is negative 3. Now we should see if we can factor this. Now, if this were a perfect square like 4, it'd be easy because you do x minus 2 and x plus 2, right? That's that difference of squares rule. But 3 is not a perfect square. So you're not going to be able to factor this. Like, you can sit there and think, what can I FOIL out that would give me this back? But you're not going to find anything. So we have to think, how do we solve this, though? Because remember, we want to know what makes it equal to 0. Like, we already figured out that negative 1/2 is a solution twice, right? But then we need to know, how do we get this factor to equal 0? Well, yesterday, when we couldn't factor, we usually had to use the quadratic formula. Guys, you could use the quadratic formula here because A is 1. You would just have to use 0 for B, and C is negative 3. But whenever B is 0, you don't have to use the quadratic formula. You could, but you're making too much work for yourself. Like, you can just solve this by good old algebra, like working backwards. Add 3 to both sides. So you have x squared equals 3. And just take the square root, right? Remember, some quadratic equations you can just take by solve by taking the square root. You just have to remember that when you take the square root, it could be positive or negative radical 3. So our final answer, if we wanted to write out the factorization, it would look like 4 times x plus 1/2 times x plus 1/2, and then x plus radical 3 and x minus radical 3. But again, what we really want to know is what makes it equal to 0, though. So we probably don't even really have to write out the whole factorization, but the final two solutions are going to be positive radical 3 and negative radical 3, okay? So I want to show you on your calculator real quick how to check your answers. I've mentioned this button to you before, that you can do second trace and pick value. So we've said negative 1/2 should, if we type that and hit enter, it should put us where that double 0 is. Yep, negative 1/2, 0. So then I want you to do second trace value, and let's check radical 3, or you could do negative radical 3. I'm going to do positive radical 3. Now, it doesn't, I want you to look at y for a second. It doesn't say 0, which is kind of weird, but sometimes your calculator is not quite technological enough to give you exactly 0, but that number is in scientific notation. It means 0.00000, like 11 zeros and then 2, like it's essentially 0, okay? So don't worry about the fact that it doesn't say exactly 0. What I want you to focus more on is x. See how, do you remember in the beginning I said it looked like it might be like 1.7 or 1.8? Do you remember when I guessed that back in the beginning? So look what it actually is. It's an irrational number. So I want to make sure you guys understand this connection. When we make our P over Q list, those are the possible rational zeros, okay? So if the solutions are irrational, they're not going to be in this list. That's why negative 1/2 was the only thing that worked out of our list, because it was the only rational solution. The other two solutions are irrational, okay? Or sometimes your other two solutions will be imaginary, okay? But that's why not everything's going to be in this list. I want to make sure you understand that. Only the solutions that are rational are going to be in that list. Okay, any questions so far at all? I don't know if you remember, I told you 2.7 has 3 different theorems we're going to learn. Yesterday, remember, was the fundamental theorem of algebra. It just says whatever the degree of the polynomial is, that's how many solutions there are going to be, okay? Today's theorem, there's 2 parts to it. There's something called the complex conjugate theorem. So basically that says when you're solving a polynomial, when you're looking for the solutions, if you get an imaginary number as one of your solutions, its conjugate is also going to be a solution automatically. It's like they come in pairs, okay? So I don't know if you remember the word conjugate. We learned that back in chapter 1. So conjugates are just like, we'll put an example down here at the bottom. 3 minus 2i, if you get that as a solution, its conjugate would just be 3 plus 2i. Like all you do is change the minus to a plus, or vice versa. But if 3 minus 2i is a solution, then 3 plus 2i has to also be a solution. So it's up to you what you want to write down from this slide, if you want to write the whole theorem or just the example. I might suggest at least writing like, if this is a solution, the conjugate is also going to be a solution. So the same is going to be true with irrational numbers. We saw that happen in the warm-up. Remember how radical 3 was one solution, but negative radical 3 was also a solution. So that's always going to happen with irrational numbers too. If you get like a plus radical b is a solution, its conjugate, a minus radical b, is automatically also going to be a solution. It's like, again, it's like they come in pairs. Like you can't have one be a solution and not the other. It just always happens that way, that if one of those things is a solution, its conjugate also will be. As you're finishing writing this in your notes, guys, I want to tell you what we've been doing a lot of so far is, like in this chapter, the past several days, I give you a polynomial and you have to find all the solutions, the places where it crosses the x-axis. We're actually going to go backwards now. We're going to be given the solutions of the polynomial and we're going to have to write the equation. Okay, one more thing you probably should remind yourself in your notes, that if you know a solution to a polynomial, remember the factor is always going to look like x minus this solution. If you think back to the warm-up, remember we knew it crossed the x-axis at -1/2. So technically when we write the factor, we write x minus -1/2. But whenever it's minus and negative, we change it to plus. So again, remember when the solution was -1/2, the factor looked like x plus 1/2, okay? So just something that you're going to want to keep in mind since we're going to be writing equations today. So write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So what we're going to focus most on out of all that part of the question is that we want these numbers to be the given zeros. Like if I graph this, when I'm all done writing my equation, it should cross the x-axis at -5, -1, and 2. So let's write an equation in factored form first, because I know that if a solution is -5, the factor will look like technically x minus -5, but we don't write that. We just change it to x plus 5, right? Again, think about it, because if you fill in -5, -5 plus 5 is 0, right? So then again, if we want this to be a 0, we would write x minus -1, but again, we don't write minus and a negative. We just write plus, okay? And then x minus 2. So it's very easy to write it in factored form, but most of the time it's going to ask you to put your answer in standard form. So in order to do that, we're going to have to use some of the skills we learned earlier in the chapter. We're going to have to multiply these 3 factors together. How will we do that? Well, the first 2, we're just going to FOIL, right? X times x would be x squared. Outer 1 times x, and inner 5 times x. And last, 5 times 1 is 5. But then I'm going to go ahead and 1x plus 5x is 6x. Some of you are probably so good at your foiling by this point, you would probably go straight to writing 6x without even showing outer and inner, because you might know it. Now remember, normally when we do foiling, we drop parentheses. But since we have to take that whole answer, times this, we're going to need to keep it in parentheses. Now, let's see if you remember how to multiply those two polynomials together from earlier in the chapter. So you can check your individual terms here. Again, if you want to do a box, you can, a 3x2 box. I'm just going to show like x squared times x to the first would be x to the third. Then x squared times -2 is -2x squared. Then you got to do 6x times x. That's 6x squared, right? Remember, you're adding exponents when you're multiplying. 6x times -2 is -12x. Then move on to 5 times x and 5 times -2. And then let's make sure we don't lose this because we're supposed to write a polynomial function. So we should have function notation. Let's put our answer in standard form, x to the third. -2 plus 6 is positive 4x squared. -12 plus 5 is -7x. And then you have your -10 on the end. It'd be very easy to check your work. You could graph this in your calculator. And make sure that it looks like it crosses the x-axis at the places that it wanted to cross the x-axis, okay? Now, the other stuff is set in the directions. Write a polynomial function of least degree. Well, it's going to have to be degree 3 if there's 3 solutions. And good, that's what we got, degree 3, okay? That has rational coefficients and a leading coefficient of 1. Check those things. Yes, the leading coefficient is 1. And all of these coefficients are rational. Like, remember, rational numbers are things that can be written as fractions. So normally that part of the directions, guys, is going to sort of automatically be satisfied. You're going to just mostly focus on what do I want the zeros to be. The rest of it kind of just happens naturally, okay? Let's try another one. So write a polynomial function of least degree. So we're going to be writing the function that has, again, rational coefficients and leading coefficient of 1. You don't have to pay that much attention to that. Pay more attention to the fact that we want it to have the given zeros. So we want these 3 things to be solutions. So we'll write it out in factored form first. If we want it -3 to be a solution, remember our factor would be, technically we could write it like this, but it's just going to become x plus 3, right? Because now if we plug in -3, we get 0. That's what we want. We want -3 to be a 0, a solution. Now, for 0, we could write x minus 0, but we'll talk about that more in a second. And then if we want 6 to be a solution, we'd write x minus 6 as the factor. So I want to talk to you about x minus 0. When you take away 0 from something, nothing happens, right? That means x minus 0, we can just write it as x. We don't need the minus 0 there. So guys, I'm actually going to put that x first and then write the x plus 3 and then the x minus 6. It doesn't really matter the order though, like, because multiplication's commutative. You could put the x minus 6 first if you want, then the x plus 3, then the x. It doesn't matter. I just think that this way is going to be the way that's easiest for you. And because I would just multiply from left to right now. So our first set of multiplication would just be x times x and x times 3. So that'd be 3x. But then remember, that whole answer has to get multiplied by x minus 6, which means you're going to FOIL it. So you go ahead and finish it. All right, so check your work here. X squared times x to the first would be x to the third now. -6 times 1x squared would be -6x squared. 3x times 1x would be 3x squared. And then last, 3x times -6 is -18x. So the middle terms are the only ones we can combine. So we leave x to the third alone. -6 plus 3 is going to give us -3x squared. And then minus 18x. Again, we know that 3 is good for the degree because there's 3 solutions, so that's the least degree that we could possibly have. The coefficients are rational, and this leading coefficient is a 1. So that's our answer. Again, it'd be very easy to check it. Just punch it in y equals in your calculator and make sure it really looks like it crosses the x-axis at -3, 0, and 6. Okay, a couple more here. So same question, write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros, again, I want you to focus most on that. So it gives us 3 zeros, okay? But because of this theorem, remember this one is imaginary if it's got I. So I need to go back to our theorem for a minute. If you have an imaginary solution, its conjugate is automatically going to be a solution. So, like, they don't tell you that in this question because you're supposed to know on your own that if negative 3i is a solution, positive 3i also has to be a solution, always, because of that theorem, okay? So we'll write a polynomial in factored form first. So again, we would write x minus always, but negative 1. So it would end up becoming x plus 1, then x minus 2, then x minus negative 3i, but again, that would become x plus 3i, then x minus 3i. So this will be a degree 4 this time when we're all done because there's 4 solutions. Now, guys, remember, you can multiply just from right to left if you want, like we did on the last ones. I wouldn't do it that way for a problem like this. I would FOIL out these two and write your answer, and I would FOIL out these two and write your answer. So I'm going to actually have you do that on your own. Okay, so over here, x times x is x squared. Outer would give me negative 2x. Inner would give me positive 1x. Negative 2 times 1 is negative 2. Over here, x times x is x squared. Outer would give me negative 3 times I times x, but inner would give me positive 3 times I times x. Those are going to cancel. We'll talk about that in a minute. Look at the last. 3 times 3 is negative 9. 3 times negative 3, sorry, is negative 9, and I times I is I squared. So let's talk about this real quick. In the red, these add up to negative 1, so we would just end up with this. Okay, then over here, again, those middle terms are going to cancel out because negative 3 plus 3 of the same thing, they're both IX's, like they're like terms, it adds up to 0. Now remember, I squared equals negative 1. We learned that back in chapter 1. So that's like negative 9 times negative 1. That's just going to end up being positive 9. So if we want to go on from here, again, you got to take this whole polynomial times that. So we could draw a box if we want to, a 3 by 2 box, or we can just go ahead and do the distributive property. So we'll do x squared times x squared. That's going to be x to the 4th. Outer x squared times 9 is positive 9x squared. Move on to here. Negative 1x times x squared is negative 1x to the 3rd, right? Negative 1x times 9 is negative 9x. And then negative 2 times x squared, and negative 2 times 9 is negative 18. When I go to write my final answer, guys, I want to put the terms in the right order, like standard form. So I'm going to make sure I put x to the 4th first. Then I'm going to jump and put this next, the negative 1x to the 3rd. 9x squared minus 2x squared is positive 7x squared. And then I'll just rewrite negative 9x minus 18 because there's no like terms to combine those with. Again, very easy to check your answer. Well, actually, if you did plug this in your calculator, you're only going to see it cross the x-axis at negative 1 and 2, right? Because the other two solutions are imaginary. But again, our polynomial is degree 4 since it has 4 solutions. Questions on that one at all? Okay, couple more here. Write a polynomial, same question of least degree that has rational coefficients, leading coefficient of 1, and the given zeros. So it gives us 3 zeros. Now I want to remind you guys, it could have just said this, and you need to think to yourself, because of this theorem right here, if negative radical 5 is a solution, positive radical 5 has to also be a solution. They come in pairs, okay? So again, it might not always give you both of them because you're learning that theorem. So you have to know if one of them shows up, its conjugate has to also be a solution. So let's write it in factored form first. If 4 is a solution, x minus 4 would be a factor. If negative radical 5 is a solution, x minus negative radical 5, or a better way to write it would be x plus radical 5 would be a factor, and then x minus radical 5. Now, again, guys, when you're multiplying this out, we could FOIL these two and then take the answer. Like, you could just go from left to right, but I wouldn't. Like, remember on the last one how I had you multiply the two that both involved imaginary numbers? I would multiply out the two that both involve irrational numbers, that radical 5. I'm going to give you a minute just to FOIL that to see what you get as the answer. So x times x is x squared. Outer is going to give me negative radical 5 times x. And then inner is going to give me positive radical 5 times x. And then last, I would think of 1 times negative 1, but then radical 5 times radical 5. Guys, you can write that as, since both 5s are under a radical, you can write it as one product. We learned that back in chapter 1. So then, like, this is going to cancel. That's going to add to 0, right? So let me use a different color real quick. That's going to cancel. So that's like negative 1 times radical 25, but radical 25 is just 5, right? So, like, you could check in your calculator, radical 5 times radical 5, it's just going to be 5 every time, okay? Because 25 is a perfect square. Then we should bring this down. We still got to take x minus 4 times that x squared minus 5. But notice, guys, did you see what happened? There's no more radicals in my answer. That's always going to happen because the outer and inner, when you multiply conjugates, remember the outer and inner cancel, and then the last part is a perfect square, so it ends up just being a whole number. So to finish this, we're going to do x times x squared, which would now be x to the third, negative 5 times x, negative 4 times x squared, and negative 4 times negative 5 is positive 20. There's no like terms, but it's not in standard form. Remember, we should have the x to the third first, then the x squared term, then the x term, then the constant term. Okay, again, it'd be easy to check it, plug it in your graphing calculator, and see if it crosses the x-axis at those 3 places. Okay, last question, same thing again. So I'm not going to read the whole thing, but we want to write an equation that has zeros or solutions of 3 and 2 plus radical 5. So again, you have to know, because of that new theorem we learned today, it doesn't tell us 2 minus radical 5 is also going to have to be a solution. So when we go to write it in factored form to begin with, remember, guys, again, that you're always going to write x minus the solution, because this one's going to get really tricky. So you're going to want to make sure that you're writing out notes for this one. So x minus 3 we would write. Then I'm just going to set up the other factors for a second, because what's going to get tricky is this solution has 2 parts to it, a 2 and a radical 5, so you're going to have to write it in parentheses. Same thing with this, you're going to have to write it in parentheses. So those parentheses are going to be important because I'm going to leave x minus 3 alone. This is like a negative 1, like you're going to have to distribute it to make that negative 2 and negative 1 times radical 5. So you could just write negative radical 5, but I'm going to leave it like that for a minute. So then over here, negative 1 times 2, and negative 1 times negative 1 would be positive 1 radical 5. Again, you don't really need the 1 in there, but I'm going to leave it like that for a minute, okay? So now, again, just like the last one, I don't want you to go from left to right. I don't want you to multiply those two first. I want you to multiply both the parts that have a radical in them, because, like, think ahead to when we do negative radical 5 times radical 5, that's like negative radical 25. It's a perfect square, so it's going to end up just being negative radical 5. So, guys, I want you to think how you would multiply this out, though. Each quantity has 3 things in it. Like the first one has an x, a negative 2, and a negative 1 radical 5. So you're either making a 3 by 3 box if you want to multiply this, or we're doing a lot of distributive property. So we're going to be doing x times x. We're going to be doing x times -2. We're going to be doing x times 1 radical 5. So 1x radical 5. Move on to -2 times x. -2 times -2 is +4. And -2 times 1 radical 5 is -2 radical 5. And then -1 radical 5 times x is -1x radical 5. -1 radical 5 times -2 is +2 radical 5. And then -1 radical 5 times +1 radical 5 is like -1 radical 25, but that's just 5, right? Again, radical, I'll show you off to the side. Radical 5 times radical 5 is the same as radical 25. It's just 5, okay? So you're going to have, it looks so long, it's got 9 parts to our answer, but a lot of it's going to cancel out. The x squared isn't. And then we've got -2x minus 2x. That's going to give you -4x. We've got +1x radical 5 minus 1x radical 5. So those are going to cancel. You've got 4 minus 5. So that's -1. And then -2 radical 5 plus 2 radical 5. Those are going to cancel. Look at our answer so far. It no longer has anything irrational in it. Like all the radical 5s are gone. Okay? So that's the answer from this. We still got to take this, so keep it in parentheses, times the x minus 3, which would mean box method one more time or multiply it all out. So I'll give you a minute to finish it. So we would do x times x squared. That's where we add the exponents, right? So you're going to have x to the third. X times -4 is going to give you -4x squared. X times -1, -3 times x squared. -3 times -4x is +12x. -3 times -1, +3. Combine any like terms and make sure you write your answer in standard form. So we need the highest degree first. -4 minus 3 is going to give us -7x squared. -1 plus 12 is going to give you +11x, and then we have our +3 on the end. Again, very easy to check it. You could graph it in your calculator and make sure it really crosses the x-axis at these 3 places.